All right. So let's kind of go through and do the setup here together. Excuse me, guys. Can we stop talking, please? Hi, Ty. Thank you. All right. So the place I really am kind of most concerned with on these is your guys' ability to kind of write the equations that you need to solve your system. The solving the system part shouldn't be too bad. We'll just use our calculator to kind of handle that part. But I am more interested in our ability to kind of come up with the two equations, because if we can't do that, we can't really solve the system and get a correct answer, right, if we don't have the right system to start with. Everybody okay with that idea? All right, so I'm going to lean on you guys here on this assignment to help us come up with the equations that we need to write in order to solve these systems. So if we read the first one, it says you worked 14 hours last week and earned a total of $96 before taxes. Your job as a lifeguard pays $8 per hour, and your job as a cashier pays $6 per hour. How many hours did you work at each job? So let's start by defining a variable to represent the two things we're looking for. So I'm going to use the variable L to be the hours that we spent lifeguarding, and the variable C to be the hours that we were a cashier. Everybody okay with that abbreviation? And certainly from the last sentence, you knew that those were the two things that we were looking for, right? Okay? So what's one equation that we can write based on the story problem? Good. L plus C is equal to 14. It says we worked a total of 14 hours, and the two jobs we have are lifeguarding and cashiering. L was the hours we spent lifeguarding. C was the hours we spent cashiering. So L plus C should be 14. Everybody good with that? Okay. What's the second equation that we'll have? Okay. 8L plus 6C is equal to 96. The other total in the problem that we're given was the amount of money we made that week. And we're given two rates in the problem. We make $8 per hour as a lifeguard, and as a cashier, we make $6 per hour. So if we take that rate and multiply by the hours we spent doing each of the respective jobs, we should get the total income for the week, right? Okay. So once this system is good, those two equations are correct. Once you have that, you can enter those into a matrix and use the RREF is what I would do to solve them. You should have gotten 6 hours as a lifeguard and 8 hours cashiering. Does anybody still have questions about how to get these in your calculator and get the answer to come out? Okay, good. I won't bother to show that to you anymore. It feels like everybody feels good about that. We did quite a bit of practice on that in the last assignment, so you should feel reasonably confident that you can get that into your calculator and get the answer to come out. Let's look at the next one then. Again, it seems to me like the bigger issue is going to be the writing the equation, right? That's certainly what it appeared in the previous class. The second problem says, during one calendar year, a state trooper issued a total of 375 citations for warnings and speeding tickets. Of these, 37 more warnings, or I'm sorry, there were 37 more warnings and speeding tickets. How many warnings and speeding tickets were issued? So I'm going to use W to represent the number of warnings and S to be the number of speeding tickets. Okay, so we'll set up our system then. We should, because we have two variables, how many equations are we going to need for this system? 2. Okay, what's one of the equations that I can write here? W plus S equals 375. Very good. So again, we're given a total here. So that's usually a good indicator that you're probably going to just be looking at the sum of the two variables has to equal that whatever that total is. Everybody okay with that? Okay. What's the second equation going to be? Well, it's going to come from that sentence, right? It says, of these, there were 37 more warnings than speeding tickets. So which one is there more of, warnings or speeding tickets? Warnings, right? So if I had 10 speeding tickets, how many warnings would you expect to have? 10 plus 37, or 47, right? So that tells me how to write the equation. So I know that the warnings should equal 37 plus the number of speeding tickets. Everybody okay with that idea? And you see that trick that I did where I made it numeric before I wrote the equation? If you're like, oh, is that 37, is it W equals 37 plus S, or is it S equals 37 plus W? If you're not quite sure, like, pick some numbers and see if it like makes sense the way that you did it, right? Intuitively, we knew how to add them together just by reading the sentence, but translating that sentence into symbols is sometimes a little tricky. But if you pick numbers and like, oh, did my equation make sense with the numbers for the sentence? It usually gives you a pretty good indication of whether you did that correctly. Now, the way this is set up, can I type this into my calculator the way this is set up? No, right? What's the issue? My S's are on different sides of the equal sign. You guys see that? So before I can put this into my calculator, I have to rearrange that second equation. I can just subtract S from both sides, though, and then I fixed it. Notice now that the W's line up, the S's line up, the equal sign lines up, and then like the solution lines up. So it's all set to be entered into a matrix now. If those things don't all line up, you can't just type it into the matrix all willy-nilly and do the RREF and expect to get the correct answer. Everything has to kind of line up before you can get it into the matrix. So there we had a little bit of rearranging to do, but it wasn't bad, right? It was an easy rearrangement. Is everybody okay with that one? When I do that, I should have gotten 169 speeding tickets and 206 warnings. If you solve that out with your calculator, that's the answer you get. And again, everybody's cool with getting this into our calculator and getting an answer to come out, right? Yep. I'm going to go press second and then the matrix command. I'm going to go to the edit tab pick one of these matrices. I'm going to just pick matrix A. Now the matrix that I need is a 2 by 3. And the entries that I'm going to put in are going to be the coefficients for each row or each equation. So the first one has coefficient 1, 1, and then 375. So 1, 1, 3, 7, 5. The next equation has coefficients 1, negative 1, and 37. So 1, negative 1, and 37. Okay, now that I have the matrix entered into my calculator, I'll exit back to the main screen, go back into the matrix menu, but this time go to the Math tab. From the Math tab, I'm going to scroll down towards the bottom until I find the command RREF. So I'll select that. And then I'm going to perform the RREF on that matrix that I just made. In my case, it's matrix A. And I'll just close the parentheses and press Enter. So this matrix tells me my solution. It says that 1W plus 0S is equal to 206, or just W is equal to 206. And 0W plus 1S is equal to 169, or just S is equal to 169. Okay with that? Like story problem ones? Probably just one. I'll talk about what the test format's going to look like here in a little bit. But again, I'm trying to be realistic about how much you can do in a 65-minute test. But if you know what to do, like a story problem like this, if you can write the system, after that it's like a minute or two to solve it, right? The hard part is getting the system written. So number 3 says a nut wholesaler sells a mix of peanuts and cashews. The wholesaler charges $2.80 per pound of peanuts, $5.30 per pound of cashews, and sells the mix for $3.30 per pound. How many pounds of peanuts and how many pounds of cashews should be made to make 100 pounds of this mix? I'm going to use P for the pounds of peanuts and C for the pounds of cashews. Everybody good with that? Okay. So 2 variables, I should have 2 equations here. What's one of the equations that I can write? Not P plus C equals 330, because that's P is pounds and C is pounds. If I add pounds and pounds together, I shouldn't be getting dollars, right? Which is what the 330 is. P plus C equals 100, right? I'm good with that. Great. Does everybody agree with that? The units here kind of helped us know what stuff needs to go together and not go together. Good. What's another equation I can write here? Caden? Okay, so 2.8p plus 5.3c. Again, like you can say 530 or whatever. I just drop the zeros because I don't need them. You know what I mean? And then equals what? Okay. So it'd be tempting to write it this way, right? Between the two, you and Nancy, basically this is the equation that you guys are describing. Not quite right, though. So let's think about the units here for just 1 second. Zach, I'll be right with you, okay? So this is $2.80 per pound times pounds. The unit resulting would be just dollars, right? So I would have dollars plus dollars equals dollars per pound, which is not quite right. The units don't quite match up. So we do need to multiply the 3.3 by some amount of pounds to make the units match up. Do you guys see that? Does that make sense? What amount of pounds do we need to multiply that by? 100, right? Because the 3.3 is the amount, or the pounds or dollars per pound for the mix. So we need to multiply it by the pounds of the mix. This was probably the trickiest one to get set up correctly. I'm guessing that not a lot of us caught that we needed the times 100 on the 3.3 there. But once you've seen that trick and why that's the case, you're more apt to recognize it in the future. But that's not easy to notice right away. When we solve that out, we get 80 pounds of peanuts and 20 pounds of cashews. Zach, you had something that you're going to... Yeah, so the issue is that the variables need to be P and C in both equations, or else you end up with, like, now you have three variables if you're introducing a third one, so you need a third equation, and there's not enough information to write a third equation in that regard. So, yeah, I get where you're saying it's tempting to kind of like, oh, okay, we'll make like some average amount of cost or something. But you see where the issue is, right? Everybody's okay with that, Ben? All right. 4. How many variables are there in question 4? 3. So I'm going to use P for the cost of the pizza, L for the cost of the liter of soda, and S for the cost of the salad. Again, the last sentence there is basically telling you that we're looking for 3 variables. There's 3 quantities that we want, right? Okay. So who can tell me one of the 3 equations that I would use here? Caden? Mm-hmm. Let's use L for the liter of soda. That's okay. And then plus S equals 14. Very good. So all Caden did was use this sentence right here. Basically told us exactly what the equation was going to be, right? 2 pizzas, 1 liter soda, 1 salad, and it costs $14. Everybody's okay with that? Yeah, again, like, here I'm just naming them so, like, it's easier for me to remember, like, which one is what, like, what did I find? If it's me, like, I'm going to get confused halfway through if S or X was that the pizza or was that the soda? What was X again? If I name it, with the letters, those letters, it just makes it easier for me to keep track of what it is I'm finding. You can use whatever letters you want, though. It's not a big deal. Zach? Sure. Okay. What's the next equation I can write then? Yep. And then the last equation. Good. And I love that Nancy put +0 there, because when I type this into a matrix, I have to make sure that I remember to put a 0 where the S variable would go, even though there's no salads in that final order. When I enter it into a matrix, I got to make sure I put the 0 there so things all line up correctly for me. When I solved that, the pizza was $5, the liter of soda is $1, and the salad was $3. That one wasn't too bad, though, right? Getting the system out of that. Nothing really tricky about that. It basically described it per each sentence exactly the equation to write. Wasn't anything sneaky going on there because there was no rates involved. Okay. 5 says the attendance at a rock concert was 6,700 people. The tickets for the concert cost $40 for floor seats and $25 for all other seats. The total, income for ticket sales was $185,500. Holy smokes. How many floor seat tickets were sold? How many other tickets were sold? Right, well, F is going to be the number of floor seats then. And I'll use T for the number of other seats. And I guess let's use capital letters here. A lowercase t looks an awful like a plus sign. That feels like dangerous to me. I'm getting confused halfway through this. So I'll use a capital T. I didn't like O either because that looks a lot like a 0, and that feels like a recipe for disaster also. So I'm just going to try to be careful about my letter choice and not confuse myself because, you know, at 8 o'clock on a Friday morning, it's apt to happen, right? All right. What's one equation we can write here? F plus T equals 6,700. Everybody good with that? Okay. What's the second equation? $40F plus 25T equals 185,500. Is everybody okay with that? If it's $40 per floor seat, I need to multiply that by the number of floor seats I sell, and that'll get the money I make from the floor seats, right? If I go ahead and solve that out, we had 1,200 floor seats and 5,500 other tickets. Six. How many variables do we have in 6? Or read the last sentence. Just 2, right? So I'll use M for the cost for the meat and C for the cost of the cheese. If you read the problem, though, how many equations can I write? Yeah, there's 3 there, right? Well, let's write the 3 equations and we'll think about it some more. What's the first equation I can write? Good. And then the second equation? Very good. And the last equation? Okay. Now, I know that I can't do RREF with a 3 by 3 matrix. I'm going to get a bunch of gobbledygook there. That's not going to be good. So what do I do? Which two equations do I pick? You don't know. So if I did 1 and 2, the cheeses would be $6 per cheese and the meats would be $2 per meat. If I did equations 1 and 3, the cheeses are $0 and the meats are $6. If I do equations 2 and 3, the cheeses are $4 and the meats are $3.2 or $3.20. And it's really unclear which one of these should be going on. What can I say here about this deli? They have inconsistent pricing, right? Depending on what you're ordering, the cheese is costing a different amount per cheese, and the meat is costing a different amount per meat, depending on the platter that you're ordering, which is seems like a poor business model. I wrote this question because I distinctly remember as a high school student going to Burger King and seeing one lone guy there protesting the inconsistent cheese pricing at Burger King as a high school student. He was handing out leaflets. He was all fired up because the slice of cheese for a cheeseburger was like 20 cents, but the slice of cheese for a Whopper was like 35 cents, and was all fired up about this inconsistent cheese pricing. And I thought it was very, very strange, and it stuck with me 20 years later. But that was the idea behind this question, was remembering that story. It's a weird story, but so when you start your own restaurant, try to be consistent with your cheese pricing, or somebody's going to end up ticketing you. 7 is asking about the area for a triangle. Do I need to write a system to solve 7? No, right? We just had a formula to deal with this. So the area for my triangle is plus or minus 1/2. And then I just have the x coordinates or xy and then a 1. So it doesn't matter the order that I put in my points. So I just am going to put them in the order that it's listed. So I did 0, 0 is the first point, 5, 2 is the second point, and 3, 6 is the last point. You could have started with 3, 6. You could have started with 5, 2. It doesn't matter the point you start with. The only thing that might change is whether it's positive or negative, but the plus or minus just takes care of all that and just makes our answer positive anyways. So then I just take the determinant of that matrix with my calculator. When I do that, I got 24. And since it's a positive 24, I know the part of the formula I want is the plus part, not the minus, because it's an area, and areas need to be positive. So my answer is 12, and I think we said these were feet. Yeah, measured in feet. That's it. That's not bad, right? Should be pretty easy to do that. The formula is easy to remember, right? It's just 1/2 the determinant, and then you just list the points and with a 1 to fill out the rest of the matrix. For 8, we're asked to write the standard form quadratic that passes through the 3 points that are given. Well, I remember that a standard form quadratic looks like ax squared plus bx plus c is equal to y. So I can use that to generate my system of 3 equations. I need a value for a, b, and c. All I'm going to do is take in the x and plug it into the x, and take the y and plug it into the y. And I'm going to do that for each point, and that'll generate 3 equations. And when I solve that, I get A equals 1.75, B is equal to 7.75, and C is equal to negative 2. So I can say then y equals 1.75x squared plus 7.25x minus 2. Everybody okay on the setup there? So the system should be easy to write. All we're using is that standard form quadratic and plugging in the values for x and y for each of the 3 points, and that generates my 3 equations that I need for my system. Should be really easy to do that, right? Easier than the story problems anyways. You know what I mean? You don't really have to think too much about how to write the equation, because you know they all look like that. Caden, what's up? I just put the value for A in for A, for B in for B, and C in for C. That's all I did. Is that cool? Okay. So the last 2 on the back are the same kind of problem. I'm just going to write down that final equation. If you guys didn't get a chance to do these, you should try them just to make sure you can get the correct answers here, but I don't think we probably need to go ahead and write those systems out. You guys seemed reasonably comfortable getting the system out of those kind of guys. Harley? Absolutely. Any final questions from this assignment? I feel like we went through all the trickiest things there, right? Okay. So this was it. This was the last topic that